This is the Pre-Calculus Regular Semester 1 Review, problems 27 to 39. Problem number 27 says graph the ellipse. This is already written in your standard form, so you need to find the center. Remember that the center is HK, and if you're not sure what H and K are, you can set each of those parentheses equal to 0 and solve for x and y. You would get 4 and negative 6. So the center is at 4 and negative 6. Always graph the center first. Then, take the square root of it. The square root of 16 is 4. That means go 4 units to the right of center and 4 units to the left of center. And then take the square root of this. See, because it's underneath of y, you're going to plot a point above and below center, which is why this was under x. You plot a point directly to the right and left of center. So the square root of 9 is 3, so you plot a point 3 units above center and a point 3 units below center, and there's your ellipse. You'll always know which way the ellipse is elongated based off of which variable has the larger number in the denominator. Since the larger denominator was under x, it should have been elongated horizontally. Problem 28 says graph the hyperbola x squared over 4 minus y squared over 9 equals 1. Since I don't see any parentheses in the numerators of those fractions, the center must be at 0, 0. With hyperbola, you need to ask yourself, how is the hyperbola going to open? Is it left and right or up and down? And that depends on which variable comes first. Since x comes first, it's going to be left and right. So the vertices are to the left and right of center. How far? Take the square root of this. They're going to be 2 to the left, 2 to the right. Well, then you're going to take the square root of this and put a point 3 units above and a point 3 units below center, and you're going to make yourself a box. The diagonals of that box are the asymptotes of your hyperbola. So the hyperbola will look like this. Number 29. Write the equation of the hyperbola, 16y squared minus 25x squared minus 96y plus 100x minus 356 equals 0 in standard form. We're going to call that factor form. So, first, we're going to determine which variable is positive, because the thing with the hyperbola is it has an x squared and a y squared, but one of them is positive and one of them is negative. Since y squared is positive, we're going to make our parentheses with y come first. So 16y squared minus 96y plus blank, because we're going to complete the square in a few minutes, plus, and we always start with plus, it will change to a minus later on, negative 25x squared plus 100x plus blank equals, we're going to move that negative 356 to the other side of the equal sign. It becomes positive 356. And since we're adding 2 new numbers to the left, we have to add 2 new numbers to the right to keep the equation balanced. But before I can complete the square, I need to make the leading coefficient of each parentheses 1. So I'm going to factor 16 out of the first parentheses, and I'm going to get y squared plus 6y plus blank. The second parentheses, we're going to factor out negative 25. That means you're going to divide both of those numbers by negative 25. So I'm going to get x squared minus 4x plus blank. Now we're ready to complete the square. You take the middle term, divide it by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. 4 divided by 2 is 2. 2 squared is 4. But those aren't the numbers that go on the other side. The numbers that go on the other side you get by multiplying these, because we originally factored out that number. Even though I didn't know what went in the blank, I really divided that blank by 16. So we factor it back in by multiplying, and 16 times 9 is 144. And negative 25 times 4 is negative 100. Now we're going to write in factor form. So I'm going to get y minus 3 squared x minus 2 squared is equal to 400. And then we're going to divide everything by 400 and reduce those fractions. 16 over 400 reduces to 1 over 25. And 25 over 400 reduces to 1 over 16. And that is the equation of the hyperbola. Problem number 30. We want to graph this piecewise function. Now remember, on the final, you're not actually graphing. You're going to have to determine which graph is the correct one. So for this particular problem, you could plug it into your calculator. We've done a piecewise in our calculator before. The way it would have to look in your calculator is you would have to put into y1 equals 6, divide by parentheses, x is less than or equal to negative 6. Remember, the less than or equal to symbol is found under the test function, second math. In y2 equals, after you put in the absolute value of x, if you have the new operating system, it just gives you the absolute value of x symbol. You can't put in that compound inequality. You have to separate it into 2. And what you do is you rewrite it as negative 6 is less than x, and x is less than 6. And is also found under the test menu. It's just when you go to the second math, you arrow one to the right to logic. And then in y3 equals, you would put in x plus 2, division sign, parentheses, x greater than 6. And then just look at the graph in your calculator, you'll figure out which one's the right one. The only thing the calculator doesn't tell you is it doesn't tell you if you should have open or closed circles. That's kind of the kicker. So let's do the first graph. The first graph is the graph of y equals 6. Now y equals 6 is a horizontal line through 6. 1, 2, 3, 4, 5. So it's this line here. Except that we want to restrict it to the x values that are less than or equal to negative 6. So I'm going to find negative 6 on the x-axis. And I hits here. And the direction where the x values are less than that is to the left. So I'm actually just going to erase the part that's to the right, and I'm going to put my circle back, and it's a closed circle. Now, the next part is the graph of the absolute value of x from negative 6 to positive 6. And one of the things you can do is you can actually just make yourself a little table of values from negative 6 to positive 6, if that helps you out. So when x is negative 6, y is 6. When x is negative 5, y is 5. When x is negative 4, y is 4. When x is negative 3, y is 3. Kind of get the gist here, so I'm going to finish. Now, I put an open circle at positive 6, and the reason that I did that is because of the inequality symbol. Now, technically there would be an open circle here as well, but since there was already a closed circle from another graph, the closed circle kind of overrides the open circle. Now we're going to graph x plus 2 when x is greater than or equal to 6. Or sorry, just greater than 6. So one way of doing this problem is to start with x is 6. So 6 plus 2 is 8. And it's going to be an open circle. And then when x is 7, you're going to get 8. And when x, or you're going to get 9, sorry. When x is 8, you're going to get 10, and then the graph just kind of goes up from there. Number 31 says solve the system of equations. I don't care how you solve the system of equations when you have 1 and 2 variables. You want to solve it using substitution, elimination. You want to solve them both for y and graph it, find the point of intersection. However you want to do it is fine. You can use a matrix for every single one of them as long as it's written in standard form being ax plus by equals c. So for this particular problem, it's set up for elimination, so that's what I'm going to use. So 12x is equal to 24, so x is 2. And now that I know what x is, I'm going to plug it back into the first equation to find out what y is. So 14 plus y is 9, so y is equal to -5, so the solution is 2, -5. However, if you had used a matrix, you would have gotten the exact same answer. When you're dealing with systems of equations in 3 variables, I would not ever try to do this via elimination. If you want to do it via elimination, that's fine, but it's going to waste a lot of time. At this point in time, you should use a matrix. The first row of your matrix should be 1, 4, -120. The second row should be 3, 2, 1, 8. And the third row should be 2, -3, 2, -16. It's a 3 by 4 matrix. So when you go into second x -1, make sure that you make it 3 by 4 if it says 2 by 3. So go into edit and then type in all your numbers. Remember to hit enter each time you enter a number or it won't lock it in. When you're done entering your numbers, you have to quit and then go back into matrix a second time, but this time you arrow 1 to the right to math and you find option B, which is RREF, and hit enter so it pops up on the home screen. And then you go back into matrix a third time, but this time you stay on names and you hit enter twice until you get this matrix. And then the fourth column should say 1, 4, -3. As long as this part of the matrix is that identity matrix, the one that has the ones on the nice diagonal, then your solution, the ordered triplet, is your last column. However, if you wanted to do this algebraically, I would have added the first 2 equations together and eliminated z. And then you would add these 2 equations together and also eliminate z. And then those 2 new equations that you just created, you would solve that system of equations to find x and y, and then once you find x and y, you can go back to one of the original 3 equations to find z. Number 33, graph the system of inequalities. As long as your inequalities are in slope-intercept form, you probably could just plug them into your calculator. And if your calculator doesn't have the inequalities program on it, that's okay. You can still figure out which side of the graph gets shaded, because if you look at what's to the left of each y value in the y equals menu, you can put the cursor here and change this, and this would be, no, it's not that one. Let's see. If you hit enter and you hit enter till this triangle pops up, this is your greater than or equal to. And then if you hit enter again, you'll see this triangle. That's your less than or equal to. The only problem is if you don't have inequals, then it doesn't show you if your graph should be dashed or solid. So we're going to just go back and do this the old-fashioned way. So you can use your graphing calculator to help you. So if you're like, I don't remember how to graph it, that's fine. You can always plug this into your graphing calculator and use the table of values to graph it. I am, however, going to use slope and intercept. So the y-intercept is 1, and the slope is -1. So I'm going to go down 1 to the right one, down 1 to the right one. I'm going to keep doing that. I'm going to go the other direction. Since the inequality symbol has a line underneath, it's a solid line. And greater than means the shading is above. The second inequality has a y-intercept of -4, and the slope is 2. So I go up 2 to the right one, up 2 to the right one. I'm going to do that a couple times. I'm going to go the other direction. Since it does not have the line under the inequality symbol, it's a dashed line. And greater than means above the line, and this would be above the line. So you'll see that the shadings are going to overlap here. Number 34, the Acme Cycle Company makes miniature bicycles and tricycles. They have 2 machines, A and B, running during the workday. Machine A takes 3 hours to make a bicycle and 4 hours to make a tricycle. Machine B takes 5 hours to make a bicycle and 2 hours to make a tricycle. Machine A can only run up to 450 hours in a week, and Machine B can only run up to 400 hours in a week. If the profit on a bicycle is $6 and the profit on a tricycle is $4, what is the maximum profit that Acme Cycle Company can make in 1 week? So the first thing you have to figure out are, what are your variables? What are you trying to find? We're going to call X the number of bicycles that the company makes, and we'll call Y the number of tricycles. So there are 2 machines running. So machine A takes 3 hours to make bicycles, and it takes 4 hours to make tricycles, and machine A can only run up to 450 hours a week. Machine B takes 5 hours to make bicycles, 2 hours to make tricycles, and it can only run up to 400 hours in a week. So we're going to graph those 2 inequalities. And remember, this is a real-world application problem. So we're only going to graph it in quadrant 1, which is why I gave you a graph here that doesn't have an axis on it. The way that we went about graphing this was we found the x and y intercept of each equation and graphed those, and since both the inequalities are less than or equal to, they are both going to get shaded underneath. So the first inequality has an x-intercept of 150 and a y-intercept of 112.5. The second inequality has an x-intercept of 80 and, I knew I was getting close to that, and a y-intercept of 200. So now I got to kind of determine how I'm going to scale my tick marks here. The best way to, so I started with 10 and I checked to see if 10 would work because I need to get to 200. And I was 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40. Well, that didn't work. So then I decided I've got to use 20s. So we're going to call this 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. So that's where my tick marks are at. And I'm going to do the same thing on the y-axis. So 20, 40, 60, 80, 100. 20, 40, 60, 80, there's going to be 200. So my first inequality is at 150, which is about here. And the y-intercept's at 112.5. So if this is 100 and the next one's 120, then 112.5 is somewhere in the middle. It doesn't really matter where. So that's a good enough interpretation of the line. The second inequality has an x-intercept at 80 and a y-intercept at 200. So there's that line. And both the shadings are underneath, so they overlap in this little figure here. Now you have to determine what the vertices of that convex polygonal set are. In other words, what are the vertices of the shaded region? Well, one of the vertices is 0, 0. Guess what? If you make no bicycles and no tricycles, you're going to make no money. One of them is at 80, 0. One of them is at 0, 112.5. You cannot make 112.5 tricycles, but we're not going to worry about that because that's not where our maximum profit's going to be anyway. And then I need to figure out what this one is. And sometimes you can't always tell by looking at the graph. Please, 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 do not guesstimate. What I want you to do is I want you to use a matrix or elimination to solve that system of equations to determine where that point of intersection is. If you use a matrix or a system of equations, you should find out that it is at 50, 75. What I haven't written yet was the profit equation. They said that the profit is $6 on the bicycles and $4 on the tricycles. So I'm going to plug each of those ordered pairs into that profit equation to determine how much money I'd make. So if I sell 80 bicycles, I'm going to make $480. If I made 112.5 tricycles, I'd make $450. But if I make 50 bicycles and 75 tricycles, I'm going to make $600. So my maximum profit would be $600. And I would get that maximum profit by making 50 bicycles and 75 tricycles. Number 35, last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets that totaled $64,600. Matinee admission costs $5. Student admission is $6 all day. And regular admission is $8.50. There were twice as many student tickets sold as matinee tickets. Write a system of equations and set up a matrix to determine how many of each type of ticket was sold. They're not asking us to solve it. They just want us to set up the system and the matrix. First of all, what are the variables? Well, there are three things going on. So there are three variables. We're going to call X the matinee admission. We'll call Y the student admission. And Z will be the regular admission. So I know if these are the number of tickets of each, the total number of tickets is 8,500. I also know how much money I made. The matinee is $5, the student is $6, and the regular admission is $8.50, and I made $64,600. The last equation in my system has to do with this equation here, or this sentence. There were twice as many student tickets sold as matinee tickets. So the number of student tickets must be twice the matinee tickets. All right, there's my system. Now the question is, what's my matrix? I'm going to get rid of this. So my first row, 1, 1, 1, 8,500. My second row, 5, 6, 8.5, 64,600. Well, what's my last row going to be? In order to write the numbers in the matrix, you've got to have your equation written in your AX plus BY plus C equals, I shouldn't write it like that, I guess. DZ is equal to C format, where C is your constant. So I actually have to write this as negative 2x plus y plus 0z is equal to 0. So my row is going to be negative 2, 1, 0, 0, and that would be the matrix you would plug into your calculator in order to solve. Number 36, Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. Write a system of equations and use a matrix to determine how many carnations were ordered. So first we're going to call the number of carnations X, the number of roses Y, and the number of daisies Z. So the first thing I'm going to do is I'm going to write a system or an equation that has to do with the total number of flowers ordered. So X plus Y plus Z is 200. The second equation has to do with the amount of money in the order. It's going to be $1.50X plus $5.75Y plus $2.60 Z is going to equal $589.50. And then the third equation has to do with the fact that they ordered 20 fewer roses than daisies. So the number of roses, Y, has to equal the number of daisies minus 20. So in order to determine the number of carnations ordered, I guess, we want to set up the matrix, which is going to be 1, 1, 1, 200. 1.5, 5.7, 5, 2.6, 589.50. But then we have to put the third equation in the correct format. I'm going to move z to the other side, so it's going to be y minus z is equal to negative 20. There's no x's, there's a y, there's a negative 1z, and the constant's negative 20. So this would be the matrix. When you solve the matrix, you should get the solution 80, 50, 70. But the problem just asked you to determine how many carnations were ordered. And since x is the number of carnations, we ordered 80. Number 37, we're going to do something similar. It's just we don't have to set up the system. The system's already there. So you're going to plug in 1, negative 2, negative 6, 3, 2, 0, negative 25, negative 4, 1, negative 1, 12. When you solve the matrix, you should get negative 2, 4, wrong answer. I'm looking at my answer key and I'm writing down the wrong problem. You should get negative 5, 3. But the question says, what's x plus y? X plus y is going to be negative 10. Number 38. Let's do it again, but this time we're going to add z and x. So you should plug in negative 5, 3, 6, 4, negative 3, 1, 5, negative 5, 4, 2, negative 4, 2, 1, 13. When you solve it, you should get 2, 4, negative 3 as your solutions. First one, I guess, it should be negative 2, 4, negative 3. And z plus x should be negative 5. And the last problem, 39, it just says write a matrix that can be used to solve the system. So it doesn't even ask you to solve it. The matrix would be negative 6, negative 2, 2, negative 8. 3, negative 2, negative 4, 8. 6, negative 2, negative 6, negative 18. And that's the Semester 1 review problems 27 to 39.